Hello everyone. Basically, personalized audiobook recommendation at Spotify through a graph neural network. What we can learn these research papers. So I think this channel, right? In this playlist, what you will learn how to read a research paper in a correct way, or what outcomes we can learn from the research paper. So this is very useful for PhD people. So this is one of the very good example. Personalized audiobook recommendation at Spotify through a graph neural network. Wow. Personalized audiobook recommendation at Spotify through a graph neural network, right? So these are the author, USA author. We need to understand Marco Nadai. This is one of the author. Francisco Favre, Paul Gigoli, Elias Wong, and Lee Fabrizio, Silvestri, Loro Kim, Swan Lin, Walden, Sandeep, David, Hughes, Borchard, Monia, Lalmas, Adro. So these are the Spotify. So we can learn what are the challenge, what are the keyword, neural network, representation learning, personalization recommend system. So we can learn each and every word in everything in detail. So we will not complete in a one shot. It will take time, but don't worry. I will be make a 2 and 3 videos, so don't worry. So first abstract. What is the abstract? First we so when you are written a research paper, so you have to written abstract. What is the abstract? Whenever you are writing any research paper, you have to written abstract. So basically a sort of piece of writing that tell your main content of the book. So this is just short piece of writing. So what is the in the ever evolving digital audio landscape, Spotify, well known for its music and talk content, has recently introduced audiobook and its vast user base. While promising this move presents significant challenges for personalized recommendation. Unlike music and podcast, audiobook initially available for a fee cannot be easily skimmed before purchase, posing higher stakes for the relevance of recommendation. Furthermore, introducing a new content type into an existing platform confront extreme data sparsity, sparsity, right? As most users are unfamiliar with this new content type. Lastly, recommending content to millions of users require the model to react fast and scalable. To address this challenge, right, you need to understand the first problem. So lastly, recommending the content to millions of users require the model react fast and be scalable. Let's understand this. Lastly, recommending content to millions of users, right? To address this challenge, we leverage. So this is a problem statement. First, we understand how to solve, how to address this problem. Now we can discuss, right? Please follow this language. I can put the few highlighter and I can bring few things. But what happen when you learn the research paper, just enjoy it. Don't be skip the things, because what happen when you skip the things, you cannot connect the dots. If you do not skip the things, you can easily connect the dots. So, so to address these challenges, we leverage podcast and music user preference and introduced the 2T-SGNN, a scalable recommendation system comprising heterogeneous graph neural network (SGNN) and two-tower model. This novel approach uncover nuance item relationship while ensuring low latency and complexity. We decouple user from the SGNN graph and the propose an innovative multi-link neighbor sample. These choices, together with the 2N component, significantly reduce the complexity of the SGNN model. Empirical evolution evolving millions of users saw significant improvement in the quality of personalized recommendation, resulting in a 46% increase in new audiobooks start rate and 23% boost in streaming rates. Intriguingly, our model impact the extend beyond audiobooks, benefiting established product like podcast. Now we need to understand keyword. Keywords is then when we can understand what are the keyword. Graph neural network. You understand the neural network, but you never understand, never see of the graph neural network. Representation learning, personalization recommendation system, recommend personalized recommender system. ECM reference format, Marco Di Nadai, Farco Fabri, these are the reference format. Paul Gigoli, Elias Wong, Ang Lee, Fabrizio Silverstreet, Laura Kim, Solin, Walden, Sandeep, and David Hughes, Andres. So these are the Spotify through. The other contribute equally to this research. So these are the other. This was not a single person effort. These are the 20% of people who did that. So see the research paper, we can skip it. But what happened? Each and every line is very important to connect the dot, to understand the problem statement, to provide the proper solution. What type of solution they provided. So we can understand the mindset of the author also. So I would recommend it whenever you read the research paper. I would suggest you go and learn it slowly and problem statement solution and what are the solution what are the keyword each and every keyword also every word in the research paper. You cannot skip it. Take a time. You don't need to hurry because what I understood that whenever you have a patience to understand the research paper, you have a your mind is quick to learn the things, right? So I would suggest try to learn it. I can give you few introduction now. Audiobook trace their root in the ancient traditional of narrative oral storytelling. Despite, right? This line is still amazing. See, audiobooks trace their roots in the ancient tradition of narrative oral storytelling. Despite representing just 7% of border of book market, their annual consumption growth rate of 20% high market, their annual consumption of growth rate 20% highlight the increasing the need of personalized recommendation. Spotify, a leading audio streaming platform, you don't know, serving hundreds of millions of users, recently added an audiobook to its extensive catalog, which already include millions of music track and podcast. While music and podcast are consolidated on Spotify, right? You have seen lot of podcasts in the Spotify, you have seen lot of music. Are most user are familiar with the new content type. Therefore, it is challenging to develop an audiobook recommendation system that leverage scatter user interaction and seamlessly fit into the current platform. Right? Definitely. The problem statement is very good. The introduction we understood. I am not explaining much because when you the what I'm saying, research paper, they have written that way, such a way, so anyone can read easily because the language they keep it very straightforward and simple. So I don't need to explain this thing. You read it, you can understand very quickly. So be a ready, be a slow, be a read it. So this is a way we can learn it. And whenever in the second time, when you read the research paper, you read it quickly. Oh, these are the topic we need to include it. Oh, these are the solution. This is the way we can discuss. When it's come to an audiobooks, Spotify face four main challenges. First, audiobook recommendation have not been previously studied at scale. How to best model audiobook content, understand its relationship with other audio content, and utilize available metadata for recommendation remain undetermined. Second, introducing a new content type in an existing platform face the extreme cold start challenges of data scarcity. Right? The second. The third, although Spotify has now include audiobook as part of Spotify premium subscription, they were initially launched under the direct sales model. So they have a model, direct sales model. This sales model might influence user to have lower risk tolerance, thus creating a higher stake for the relevancy and accuracy of audiobook recommendation. Furthermore, this model limits to the volume of explicit positive interaction signals such as stream and purchase required to use of implicit signals to overcome interaction sparsity. Finally, integrating a new product into an existing platform requires the recommendation system to be efficient, scalable, and modular. The model has to serve hundreds of millions of users with minimum latency and be flexible enough to accommodate evolving user interaction and product feature. Modularity is also crucial to ensure the model component can be adapted the reuse in the various project and contexts. For example, personalized recommendations on the page and research is good, right? In response to these challenges, right? We understand the challenges, right? The introduction part. In response these challenges, we represent 2T SGNN as scalable modular graph-based recommendation system that combines heterogeneous graph neural network with the two tower model, ensuring effective recommendation for all users with only minimum latency. For eligible premium user have access audiobook selected countries. Right? The model looks good, right? I don't need to explain, right? First we read it. Basically we read it, then I will go for the explanation, right? We conducted through data analysis and found the user podcast consumption is critical to understanding user audio preference. Moreover, through data analysis, we confirm our intuition be implicit signals such as follow and previews are the beneficial to predict the future user purchase and stream. Definitely, if we follow that author, that musician, or we preview, we can understand. Thus, our 2G and HGS and leverage implicit and explicit signal for multiple content types to perform personalized recommendation. Our model combined the strength of SGNN and T model. While the SGNN generate comprehensive long-range item representation based on the content and user preference. The 2D model enable the scalable recommendation for all users and real-time serving with low latency during inference. Our solution decouples the recommendation task into item component via SGNN and the user item component. Via 2T model, the decoupling lead to significant smaller the trust table graph between the item only which we call listening graph, right? The co-listening graph is the combination of SGNN and with 2D reduce the SGNN inherent complexity of retrieving aggregate neighbor nodes and ensure the scalability. The modular of recommendation system offer valuable flexibility. These modular component can seamlessly integrate to existing module and Spotify. Additionally, these separation allow us to make adaptation and change the SGNN without direct user exposure, causing significant disruption. While leveraging an existing product to model a new product provide a significant benefit. There is an inherent imbalance favoring the existing content type in the user interaction. To address this issue, we introduce a balanced sampler that optimize the SGNN training for multiple age type by under sampling the majority age type. This graph is sampler effectively capture the representation of all content types and reduce the training time by approximately 60%. Figure 1 overview our model and data aggregation based on a podcast and audio book streaming user interaction. We construct the co-listening graph. In this graph, nodes represent the audiobook and the podcast and are connected by age whenever at least one user stream both nodes. Nodes incorporate contain signal for feature extract by the large language model from audiobook and podcast description. Thus, using the 2T SGNNY build embedding capturing non-trivial long-range dependencies perform the recommendation based on both content user preference. Simultaneously, learning from new and more established content type. Right. The summarize our key contribution are to our knowledge. R is the first book that deeply investigate and the design of an audiobook recommendation system at scale. We show how consumption of podcasts, which are usually shorter and more conversational than audiobook, can effective help to understand user audiobook preference. We propose a module architecture that seamlessly integrate audiobook content into an existing recommendation system platform, combining a SGNN and 2D model in a one stack. We decouple user from the graph and learn content and user preference on co-listening graph. The SGNN learns long-range nuance relationship between items in the graph, while 2T model learns use to test of audiobook for all user, including call start user in scalable manner. Right? User streaming. These are the male and female audiobook podcast. Audiobook king, right? Then co-listening graph, podcast, audiobook, and this one. Content preference. The male can be a audiobook, right? What we understood this. Anyone guessing? Okay, I will explain in the figure. Figure one. our user consumption pattern, which involve audiobook and podcast. We build a co-listening graph with node representing audiobook or podcast and edges connected nodes whenever at least one user stream both. Audio IT get recommended because 2TSG and a preform non-trivial recommendation using two hop distant pattern. Delicious is a similar to test. Test is the co-listening with the fake doctors which is co-listening with IIT to deal with the imbalance in the data distribution, right? That to deal with the imbalance in the data distribution, we first incorporate a novel A sampler in the SGNN that integrate the weak signal in the user representation when generating user audiobook prediction. We conduct an extensive offline re-experiment demonstrating the efficiency of effectiveness of 2T-SGNN. It consistently outperforms alternative method. Furthermore, our validation using an A/B test involving millions of users resulted in significant 23 increase in audiobook stream rate. Remarkably, we observe a 46 surge in the rate of people starting a new audiobook. The model is since then a production exposed all the eligible audiobooks a Spotify user. Now we will take a break. Related work. What are the related work? What are the data type, the graph? And these are the interesting. I will teach you hundred of research paper, right? ML research paper. You will learn it, love it a lot. So I will take a short break and we'll start another topic in the next video. Thank you everyone. Please like, subscribe and